Hello AP Statistics students, got another JASP tutorial for you here. With this one we're going to take a look at linear regression. So like just last time, you got to first open up your data set. You need to save it as a CSV. So I've got my data set here, and now I want to check out the relationship between two quantitative variables. So first step, hopefully pretty easy. You're going to come up here to regression. Shocker, I know. All right, now this is actually a two-step process, which took me a bit to figure out. So first you got to go correlation. All right, so click on correlation, and you're going to put both variables into the variables box, both of them in the same one. So I'm going to take a look at GPA and math score. This isn't one of the ones you're doing, so don't copy me exactly here, but I'm going to take a look at, does GPA help predict math score? All right, so a couple of clicks you got to do here. This one, display pairwise. Not exactly sure why, but what that gives me now is the R value. So we have a 0.25 correlation here, so it's positive, but pretty weak, isn't it? 0.25 as an R value is pretty weak. And at some point, you want to start clicking on things, see what some of these do. Confidence interval, it'll give me a confidence interval for the R value. That's pretty cool. So it can actually have a confidence value for that. Let's see here. Oh, scatter plot. I want a scatter plot. So I'm going to click scatter plot. And there it gives me a scatter plot. You can then resize all these graphs as well. All right, make it a little bit bigger there. Yeah, it does look positively correlated, but definitely not that much. And if you even take a look, this confidence interval just barely crosses 0, doesn't it? Although if my alternative hypothesis, if I think it's positive, it might get a one-tailed test instead of a two-tailed test. Yeah, then it changes just barely. It's just barely above 0. That time my p-value for that is 0.02, so that would fail to, or that would reject the null there, wouldn't it? And we would take the alternative hypothesis that it is positively correlated. But again, you can play around with it. There's actually a lot of cool things. This one's a pretty cool one. If you hit density for variables, it'll show you how the x and the y are distributed. I think that's one of the conditions, isn't it? The y value has to be normally distributed or something, and that's fairly normal. But I'll keep it simple here. All right, so we've got our correlation. Now it's time for a few other things. Next, go back to regression. And now we're going to do linear regression. The actual linear regression for the trend line and everything is there, not under correlation. So this will give us another menu. See how it minimized my correlation? I'm now on linear regression. And so I need to put in, let's see, my x is my independent and my y is my dependent. So my y was math, so I'm going to put that under dependent variable right there. And then the x goes under covariates. Now this is a pretty high-end program, so it can do multivariable analysis and not just two contributors to this prediction. I think you can put multiple variables in here. But in this class, we're just doing one. So I'm going to throw GPA and have GPA predict math scores here. All right, and I believe that filled in, yep, down here is my linear regression analysis. So I've got my intercept and my slope right here. So that will give us y equals a plus bx for our linear regression model. Now this is kind of cool. The null hypothesis is that there is no slope. So the null hypothesis is that you got a flat line, all right, and that's the best indicator you can give. If I want to know someone's math score, the best I could do to predict is use the average. And so the average math score is 52. So that's the intercept for a flat line. That's the null. The alternative hypothesis is that we have a slope. Okay? That we have a positive slope in this case. I think I did the one tail. And so we have our t statistic over here at the bottom right, and our p-value of 0.056, which is, again, you would possibly fail to reject because that p-value is actually kind of big. And we can put some of that in here. Let's go. Let's see our model. Is there anything we want there? I don't think so. Let's go statistics. Click on a few things here, I think. Yeah, confidence interval. There, now we have a confidence interval for our slope. All right, so over here, our 95% confidence interval. And as you can see, yeah, that 95% confidence interval for slope straddles 0. So 0 is just barely a plausible value for the slope. And so this is kind of not statistically significant. All right, 0 is still a possible value. This positive slope could have happened by random chance alone. There might not really be an association between GPA and the math scores. That's a little angering, isn't it? But again, play around with some of these things. I think I've got the basics for you. What's under plots? Oh no, there's one more. Good, look at that. Good thing I kept clicking. Don't you think it might be nice to have a residual plot? So remember, dependent is the y, covariate is the x, and predicted. There's many different residuals you can pick. It doesn't really matter which one. I'm going to do with the x. And take a look at that residual plot. Looks pretty good, doesn't it? Definitely a linear association that's nice and evenly spread. So that definitely passes that condition for us nicely. But there's other things you could do. We could have done residuals versus predicted. All right, also nicely spread. We see the same info. When I did this one, it looked kind of weird. Yeah, I don't know what that's about. Not sure. The other two look good, though. But feel free to keep clicking on things, but I think that's pretty much everything you would want in your report. A lot of this stuff you can ignore, but this one is pretty important here, especially with the confidence intervals. And the graph here, you can put all of those into your report quite nicely. Oh, and one other thing, since you made it to the end of the video, you get this tidbit. One thing I found that it can't do, or at least I haven't figured out how, is a 2-prop z test or interval. I haven't found a way to do that with this program. Maybe that's just too basic for it. I think it might be this one, but it's way too complicated for a simple 2-prop z, I think. So you might have to do the 2-prop z by hand. Thankfully, that's pretty easy. See ya.